Beneath the restless surface of our oceans lies a hidden world of extraordinary secrets. Ancient streets where merchants once traded exotic goods now serve as highways for schools of fish. Temple columns that once reached toward the sky now stand sentinel in the eternal twilight of the deep. These are the lost cities beneath the waves, civilizations that vanished into the depths through catastrophe, time, or rising seas. For millennia, humanity has told stories of great cities that disappeared beneath the ocean's surface. The most famous is Atlantis, Plato's legendary island that sank in a single day and night. But while Atlantis remains a myth, real sunken cities have been discovered across our planet's oceans, revealing truths more remarkable than fiction. Today, we journey into the depths to explore these drowned worlds. Using cutting-edge technology, marine archaeologists are rewriting history, one barnacle-encrusted artifact at a time. From the Mediterranean to the Pacific, these underwater ruins tell the story of humanity's complex relationship with the sea and serve as sobering reminders of nature's awesome power. The ocean covers more than 70% of Earth's surface, yet we have explored less than 5% of it. How many lost cities remain hidden in the abyss? What secrets do they hold about our past, and what warnings might they carry for our future? The story begins over 2,000 years ago in ancient Athens, where the philosopher Plato penned one of history's most enduring mysteries. In his dialogues Timaeus and Critias, written around 360 BC, Plato described Atlantis as a powerful naval empire located beyond the Pillars of Hercules, what we now call the Strait of Gibraltar. According to Plato's account, Atlantis was a technological marvel, a circular island with alternating rings of land and water connected by tunnels. The Atlanteans possessed advanced metallurgy, engineering, and navigation skills that far exceeded those of their contemporaries. Their capital city gleamed with walls covered in brass, tin, and the mysterious metal orichalcum, which Plato described as more precious than gold. But the Atlanteans grew corrupt and aggressive, attempting to conquer Athens and Egypt. In response to their hubris, the gods unleashed earthquakes and floods that caused the entire island to sink beneath the waves in a single day and night of misfortune, around 9,600 BC according to Plato's timeline. Modern scholars debate whether Plato intended Atlantis as historical fact or philosophical allegory. Many believe he created the story to illustrate the dangers of imperial ambition and moral decay. The timing of the tale, coinciding with Athens' own imperial ambitions, suggests Plato was using Atlantis as a cautionary mirror for his contemporaries. Yet the story's power transcended philosophy. Throughout history, explorers, archaeologists, and dreamers have searched for the lost continent. Proposed locations have ranged from the Mediterranean to the Caribbean, from Antarctica to the Sahara Desert. None have provided definitive proof, but the search for Atlantis has led to remarkable real discoveries. In the 20th century, some researchers pointed to the Minoan civilization on the Greek island of Santorini as a possible inspiration for Atlantis. Around 1600 BC, a catastrophic volcanic eruption devastated the island, creating a massive tsunami that may have contributed to the decline of Minoan civilization. The advanced Minoan culture, with its sophisticated palaces, indoor plumbing, and maritime empire, certainly possessed many Atlantean characteristics. Others have suggested that rising sea levels at the end of the last ice age may have inspired flood myths found in cultures worldwide, from the Epic of Gilgamesh to the biblical story of Noah. As glaciers melted and oceans rose by over 300 feet, vast coastal settlements would have been submerged, perhaps creating collective memories of lost lands beneath the waves. While Atlantis itself remains elusive, the search for it has revealed something even more extraordinary: real sunken cities that demonstrate the ocean's power to swallow entire civilizations. These discoveries prove that Plato's vision, while perhaps fictional, was rooted in a very real phenomenon that has shaped human history. The line between myth and reality blurs in the depths of the ocean, where archaeological evidence emerges from the shadows to illuminate our past. And sometimes, the truth is more incredible than the legend. The lost city of Heracleion, which was once the largest port in Egypt, was discovered underwater after more than 2,000 years in the year 2000. Located in Egypt's Abu Qir Bay near Alexandria, this remarkable city spent over a millennium beneath the Mediterranean before French marine archaeologist Frank Gaudiot and his team brought it back into the light. The ancient sunken city of Heracleion was discovered 10 meters, 32.8 feet, below the surface and 6.5 kilometers, 4 miles, from the present-day coastline in the western part of Abu Qir Bay. What they found defied imagination. An entire port city preserved in sediment and salt water, its buildings, statues, and artifacts frozen in time like an ancient Pompeii beneath the waves. Thonis Heracleion served as Egypt's primary Mediterranean port for centuries, a cosmopolitan hub where Greek merchants mingled with Egyptian priests and goods from across the known world changed hands. The city held particular religious significance as the location where the god Amun was believed to manifest, drawing pilgrims from across the ancient world. Among the many treasures that have been unearthed from the sunken city since its discovery were 64 ships, 700 anchors, a trove of gold coins, statues 5 meters in height, and perhaps most prominently, the remains of a huge temple to the god Amun-Gereb. The scale of maritime activity is staggering. More than 700 discovered ancient anchors of various forms, and 125 identified wrecks dating from the 6th to the 2nd century BC, are also an eloquent testimony to the intensity of maritime activity here. The artifacts tell stories of daily life frozen in time. Archaeological treasures, including Greek ceramics and 2,400-year-old wicker baskets filled with fruit, have been discovered at the site of the ancient sunken city of Thonis Heracleion off Egypt's coast. These organic materials, preserved by the unique underwater conditions, provide unprecedented insights into ancient life. Recent discoveries continue to amaze researchers. Gold objects, jewelry, and a jed pilar, symbol of stability, made of lapis lazuli, were retrieved. The city's submersion appears to have been gradual, caused by a combination of rising sea levels, ground subsidence, and possibly earthquakes that slowly lowered the land beneath the waves. Off the southern coast of Greece's Peloponnese Peninsula lies an even more ancient wonder. Pavlopetri is the oldest underwater city in the world. Archaeologists have determined that Pavlopetri dates from Minoan times, over 5,000 years ago. This remarkable settlement predates the famous ruins of Troy and rivals the antiquity of the Great Pyramids of Giza. Discovered in 1967 by Nicholas Fleming, the ceramics recovered confirm the Mycenaean occupation of the site, but also reveal occupation as early as 3500 BC, making Pavlopetri at over 5,000 years old, the oldest known submerged town in the world. The site lies just 4 meters below the surface, making it accessible to divers while remaining remarkably preserved. Pavlopetri, a representation of life 5,000 years ago, was exceptionally well planned, with streets, 2-story homes with gardens, temples, cemeteries, and a sophisticated water management system with channels and water pipelines. The level of urban planning evident at Pavlopetri challenges assumptions about Bronze Age civilization, revealing a society with advanced engineering knowledge and sophisticated social organization. The town's layout suggests it was a thriving commercial center. There is evidence that Pavlopetri served as a trading hub. Its strategic location would have made it an ideal stopping point for Bronze Age merchants trading between the Aegean Islands and the broader Mediterranean world. Pavlopetri, which literally translates to Paul's Stone, is one of the oldest submerged cities, as well as the oldest in the Mediterranean Sea. The settlement contains Neolithic and Bronze Age material, and it is believed to have flourished between 3000 and 1000 BC. The site's long occupation. The ocean is both humanity's greatest highway and its most formidable adversary. Throughout history, natural disasters have claimed entire coastal civilizations, sending their achievements into the depths. Understanding these catastrophic events provides crucial insights into the forces that shaped our past and continue to threaten our present. Earthquakes rank among the most devastating forces capable of drowning cities. When tectonic plates shift beneath the ocean floor, the results can be catastrophic for coastal settlements. The phenomenon of cozy-ismic subsidence, where earthquake activity causes land to suddenly sink, can drop entire regions below sea level in a matter of minutes. The ancient city of Heracleion likely fell victim to this process. Located in the geologically active Nile Delta region, the city experienced gradual subsidence over centuries, exacerbated by the natural settling of Nile sediments and possibly accelerated by seismic activity. The soft alluvial soil of the delta made the area particularly vulnerable to liquefaction during earthquakes, causing buildings to sink into the saturated ground. Pavlopetri's submersion tells a similar story. The Peloponnese Peninsula sits in one of the Mediterranean's most seismically active regions, where the African and Eurasian tectonic plates meet. Archaeological evidence suggests the city sank gradually over centuries, likely due to a combination of tectonic subsidence and rising sea levels following the last ice age. Volcanic eruptions represent perhaps the most dramatic way civilizations can vanish beneath the waves. The explosive power of volcanic events can trigger massive tsunamis, while the accompanying earthquakes can cause catastrophic land subsidence. The most famous example remains the Minoan civilization on Santorini. Around 1600 BC, the Thera eruption devastated the Aegean. This cataclysmic event, one of the largest volcanic eruptions in recorded history, ejected an estimated 30 cubic kilometers of material into the atmosphere. The explosion collapsed the volcanic caldera, creating a tsunami that reached heights of up to 35 meters as it spread across the Mediterranean. The eruption's effects extended far beyond Santorini itself. Ash deposits from the explosion have been found in ice cores from Greenland and sediment cores from the Black Sea, indicating the global scale of the catastrophe. The tsunami waves likely devastated coastal settlements throughout the eastern Mediterranean, potentially contributing to the collapse of the Minoan civilization. This catastrophe may have inspired not only the Atlantis myth, but also various flood legends found in cultures throughout the region. The sudden and total destruction of a sophisticated maritime civilization would have left a lasting impression on survivors and neighboring peoples, becoming embedded in their collective memory and oral traditions. While dramatic disasters capture our imagination, the gradual rise of sea levels has claimed more coastal settlements than any single catastrophic event. Since the peak of the last ice age approximately 20,000 years ago, global sea levels have risen by more than 120 meters, submerging vast areas of previously habitable land. This process, known as post-glacial rebound and marine transgression, transformed the world's coastlines. Land bridges that once connected continents disappeared beneath the waves. Rivers that flowed hundreds of kilometers farther to the sea were drowned, creating vast underwater valleys and canyons that now serve as highways for marine life. Early human settlements, naturally concentrated along coastlines and river mouths for access to water and marine resources, found themselves gradually overwhelmed by rising waters. Archaeological evidence suggests that many communities attempted to adapt by building seawalls, raising building foundations, or retreating inland. However, the relentless advance of the ocean ultimately proved unstoppable. Tsunamis represent one of the most sudden and devastating ways coastal cities can be destroyed. These massive waves, typically generated by underwater earthquakes, volcanic eruptions, or submarine landslides, can travel across entire ocean basins at jet aircraft speeds before unleashing their fury on distant shores. Historical records and geological evidence reveal numerous instances where tsunamis have wiped out coastal civilizations. The waves not only destroy surface structures, but can also cause massive erosion and sedimentation that buries archaeological remains beneath layers of marine sediment. The 2004 Indian Ocean tsunami provided a modern demonstration of this destructive power, revealing how quickly entire coastal communities can vanish. Archaeological sites along affected coastlines were dramatically altered, with some previously unknown ruins exposed by the retreating waters, while others were buried under tons of debris. Climate change has repeatedly reshaped human civilization throughout history, often working in conjunction with other natural disasters to overwhelm coastal settlements. During periods of global warming, such as the medieval warm period, rising sea levels and changing weather patterns stressed coastal communities. Conversely, Cooling periods like the Little Ice Age could trigger different types of disasters, including increased storm activity and changes in ocean currents that affected navigation and fishing. These climate-driven changes often created cascading effects, weakening civilizations and making them more vulnerable to other natural disasters. The story of drowned cities serves as a powerful reminder that human civilization, despite its technological achievements, remains vulnerable to natural forces beyond our control. As we face our own era, the exploration of underwater archaeological sites represents one of humanity's greatest technical challenges. Working in an environment hostile to human life, where pressure increases with every meter of depth and visibility can vanish in moments, marine archaeologists have developed revolutionary technologies that have transformed our understanding of the past. The foundation of modern underwater archaeology rests on sonar technology, which uses sound waves to peer through murky water and map the seafloor with unprecedented accuracy. Side-scan sonar, deployed from surface vessels or autonomous underwater vehicles, creates detailed acoustic images of the ocean bottom, revealing anomalies that might indicate human construction. Multi-beam sonar systems generate three-dimensional maps of underwater terrain with centimeter-level precision. These systems fire dozens of acoustic beams simultaneously, creating a fan-shaped coverage pattern that can map large areas quickly while maintaining high resolution. The resulting bathymetric data reveals subtle features that might escape visual inspection, including the geometric patterns characteristic of human construction. Sub-bottom profilers penetrate beneath the seafloor sediment, revealing buried structures and stratigraphic layers that tell the story of how sites were formed and preserved. This technology proved crucial in mapping Thonis Heracleion, where centuries of Nile sediment had buried much of the ancient city beneath several meters of mud. Remotely operated vehicles, ROVs, have revolutionized underwater exploration, allowing researchers to work at depths that would be impossible or extremely dangerous for human divers. These sophisticated robots, connected to surface vessels by fiber optic tethers, carry high-definition cameras, powerful lights, and precision manipulator arms capable of delicate archaeological work. Modern ROVs can operate at depths exceeding 6,000 meters, far beyond the reach of even the most advanced diving equipment. Their stability and endurance allow for extended observation periods, while their recording capabilities create permanent documentation of discoveries. High-resolution cameras capture minute details of artifacts and architectural features, while specialized lighting systems reveal colors and textures invisible in the deep ocean's natural twilight. The manipulator arms of advanced ROVs possess incredible precision, capable of collecting fragile artifacts without damage or conducting detailed measurements with millimeter accuracy. Some systems incorporate specialized tools for archaeological work, including water dredges for careful sediment removal and sample containers that maintain artifacts in controlled environments during their journey to the surface. Autonomous underwater vehicles, AUVs, represent the cutting edge of underwater exploration technology. These self-contained robots can operate independently for hours or days, following pre-programmed missions while collecting vast amounts of data. Unlike ROVs, AUVs are not constrained by tethers, allowing them to explore large areas efficiently and access confined spaces impossible for larger systems. Advanced AUVs carry comprehensive sensor suites including high-resolution cameras, multi-beam sonar, magnetometers, and chemical sensors. They can create detailed photomosaic maps of archaeological sites, combining thousands of individual images into seamless, high-resolution overviews that reveal patterns and relationships invisible from individual photographs. The latest generation of AUVs incorporates artificial intelligence systems that can recognize and classify objects of interest, automatically adjusting their mission parameters to investigate anomalies. This capability allows for adaptive exploration strategies that maximize discovery potential while operating within the constraints of limited battery life and communication windows. While robotic systems have expanded our reach into the depths, human divers remain essential for detailed archaeological work, requiring judgment, intuition, and dexterity that robots cannot match. Technical diving technologies have evolved to support archaeologists working at increasing depths for extended periods. Rebreather technology allows divers to remain underwater for hours without the limitations of traditional scuba equipment. These closed-circuit systems recycle exhaled gas, removing carbon dioxide and adding oxygen as needed. This extends bottom time dramatically while eliminating the noise and bubbles that can disturb archaeological sites and marine life. Mixed gas breathing systems enable divers to work safely at depths where compressed air becomes toxic. Trimix and heliox breathing gases reduce nitrogen narcosis and oxygen toxicity, allowing clear thinking and precise work at depths exceeding 60 meters. Advanced decompression techniques, including the use of underwater habitats and saturation diving systems, support extended working periods at depth. Digital photogrammetry has revolutionized the documentation of underwater archaeological sites. By combining hundreds or thousands of overlapping photographs taken from multiple angles, specialized software can create detailed 3D models of artifacts, structures, and entire archaeological sites. These digital models serve multiple purposes. They create permanent records of sites as they exist at the time of discovery. They allow researchers to examine details and relationships that might not be apparent during the limited time available underwater, and they enable virtual exploration by scholars and the public worldwide. Advanced photogrammetric techniques can achieve sub-millimeter accuracy, rivaling or exceeding traditional archaeological measurement methods. The models can be manipulated to reveal hidden details, show sites from impossible viewpoints, or demonstrate how structures might have appeared when they were above water. Modern underwater archaeology increasingly relies on geographic information systems, GIS, to integrate and analyze complex datasets from multiple sources. Satellite imagery, historical maps, geological surveys, and archaeological data combine to create comprehensive pictures of how underwater sites relate to their broader geographic and historical contexts. Remote sensing techniques, including ground-penetrating radar and magnetometry, help locate buried or hidden archaeological features. These non-invasive methods can detect anomalies in sediment composition, metallic objects, or structural remains without disturbing fragile archaeological deposits. Emerging technologies promise to further transform underwater archaeology. Machine learning algorithms analyze vast datasets to identify patterns and anomalies that might indicate archaeological sites. Satellite-based remote sensing can detect subtle variations in water color or sea surface temperature that might reveal underwater features. Advanced materials, science is creating new tools and equipment that can withstand extreme underwater conditions while maintaining precision and reliability. Nanomaterials and smart sensors are enabling new types of measurements and observations impossible with conventional equipment. Perhaps most exciting is the integration of multiple technologies into comprehensive exploration systems. Modern archaeological expeditions combine satellite surveys, surface vessel operations, underwater robots, human divers, and laboratory analysis into seamless workflows that can investigate sites from initial discovery through detailed analysis with unprecedented speed and accuracy. These technological advances are not merely making underwater archaeology more efficient. They are fundamentally changing what we can discover and understand about our submerged past. Sites that were once impossible to access or analyze are now yielding their secrets to our expanding technological capabilities. The field of underwater archaeology is experiencing a golden age of discovery. Recent technological advances, combined with increased international cooperation and funding, have led to remarkable new finds that are reshaping our understanding of ancient civilizations and their relationship with the sea. These discoveries are not only revealing new sites, but also providing fresh insights into how ancient peoples adapted to changing environmental conditions. The Mediterranean Sea continues to yield extraordinary archaeological treasures. Recent expeditions in Egyptian waters have uncovered additional districts of Thonis Heracleion previously unknown to researchers. These newly discovered areas include residential quarters, industrial zones, and additional religious complexes that paint a more complete picture of daily life in this ancient port city. One of the most significant recent discoveries involves the identification of a massive ship graveyard near the ancient city. Analysis of these vessels is providing unprecedented insights into ancient shipbuilding techniques, trade routes, and naval warfare. Several of the ships contain intact cargo holds filled with amphorae, precious metals, and exotic goods that illustrate the extensive trade networks connecting Egypt with the broader Mediterranean world. In Greek waters, new surveys around Pavlopetri have revealed that the underwater city is significantly larger than originally thought. Advanced sonar mapping has identified additional districts extending several hundred meters from the previously known boundaries. These areas appear to include harbor installations, defensive walls, and what may be ceremonial complexes that suggest Pavlopetri was not merely a trading post, but a major urban center. Recent analysis of artifacts from Pavlopetri has also provided new insights into Bronze Age technology and social organization. Advanced microscopic analysis of pottery sherds has revealed evidence of specialized craft production and long-distance trade connections extending from the Balkans to North Africa. These findings suggest that Bronze Age Mediterranean societies were far more interconnected and sophisticated than previously believed. The waters around Japan and Southeast Asia have emerged as hotspots for underwater archaeological discovery. Beyond the controversial Yonaguni monument, researchers have identified numerous other underwater features that may represent ancient human activity. Some of these sites appear to be natural formations modified by humans, representing a middle ground in the ongoing debate about human construction versus natural processes. Recent discoveries off the coast of Japan include what appear to be ancient stone quarries, now submerged beneath dozens of meters of water. These sites contain evidence of systematic stone extraction and processing that could only have occurred when sea levels were much lower. Radiocarbon dating of organic materials found within these quarries suggests human activity dating back over 10,000 years. In Southeast Asian waters, rising sea levels since the last ice age have submerged vast areas of previously habitable land. Recent surveys have identified numerous underwater caves that show clear evidence of human occupation, including cave paintings, tool manufacturing sites, and burial grounds. These discoveries are providing new insights into how early human populations adapted to rapid environmental changes. The Black Sea has emerged as one of the world's most promising regions for underwater archaeological research. The sea's unique chemistry, with oxygen-depleted deep waters that prevent decay, has created conditions that preserve organic materials with extraordinary fidelity. Wooden ship hulls, textiles, and even human remains can survive for millennia in this environment. Recent expeditions have discovered intact Bronze Age settlements along what would have been the ancient coastline, now submerged beneath 100 meters of water. These sites include complete buildings with wooden beams, thatched roofs, and household artifacts still in their original positions. The level of preservation is so exceptional that researchers can study ancient construction techniques, daily life practices, and even dietary habits with unprecedented detail. One of the most remarkable recent discoveries involves a settlement that appears to have been abandoned rapidly, possibly due to sudden flooding. Analysis of the site suggests that the inhabitants had little warning of the rising waters, leaving behind complete households frozen in time. This discovery supports theories about catastrophic flooding events that may have inspired flood myths found in cultures throughout the region. Modern climate change is creating new challenges and opportunities for underwater archaeology. Rising sea levels are threatening coastal archaeological sites around the world, but they are also revealing new discoveries as changing currents and storm patterns expose previously buried remains. Recent storms in the North Sea have exposed numerous archaeological sites along the British and Dutch coasts. These discoveries include everything from medieval settlements to Stone Age hunting camps, many preserved in remarkable detail by protective layers of sand and silt. However, the same forces exposing these sites also threaten to destroy them through erosion and wave action. Climate-driven changes in ocean chemistry are also affecting the preservation of underwater archaeological sites. Ocean acidification is accelerating the corrosion of metal artifacts, and threatening the stability of stone structures. This has created new urgency in underwater archaeological research, as sites that have survived for millennia may be degrading rapidly under current conditions. Recent advances in artificial intelligence and machine learning are revolutionizing how archaeologists identify and analyze underwater sites. AI systems can now process vast amounts of sonar data to identify anomalies that might indicate human construction, dramatically accelerating the pace of site discovery. New satellite imaging technologies are enabling researchers to detect underwater archaeological features from space. Advanced sensors can identify subtle variations in water color, temperature, and surface patterns that may indicate buried structures or altered seafloor conditions. These space-based surveys are helping researchers identify promising areas for detailed underwater investigation. Advances in underwater robotics are enabling exploration of sites previously beyond reach. New generations of AUVs can operate at extreme depths for extended periods, while improved manipulator systems allow for increasingly sophisticated archaeological work. Some of the latest systems can perform detailed excavation and artifact recovery with minimal human supervision. These new discoveries are fundamentally changing our understanding of ancient civilizations and their capabilities. Evidence from underwater sites suggests that ancient peoples were far more skilled at maritime technology and navigation than previously believed. Complex trade networks, sophisticated urban planning, and advanced engineering capabilities are becoming apparent at sites around the world. The discovery of extensive underwater settlements is also challenging traditional models of how ancient civilizations developed. Rather than simple coastal villages, many of these sites represent sophisticated urban centers with complex social, economic, and religious institutions. This suggests that the development of complex civilizations may have been more geographically widespread and chronologically diverse than traditional archaeological models suggest. Perhaps most significantly, underwater archaeological discoveries are revealing how ancient peoples adapted to environmental change. Evidence from multiple sites shows that ancient civilizations developed sophisticated strategies for dealing with rising sea levels, changing climate patterns, and natural disasters. These historical examples of resilience and adaptation may provide valuable insights for modern societies facing similar environmental challenges. The field of underwater archaeology is expanding rapidly, with new projects launching around the world. As we have explored the remarkable discoveries emerging from beneath the waves, we must confront a sobering reality. The same forces that created these underwater archaeological treasures are now threatening to destroy them forever. Climate change, rising sea levels, and increasingly powerful storms are putting our submerged cultural heritage at unprecedented risk, creating an urgent race against time to document and preserve these irreplaceable windows into our past. The statistics are staggering. A 1-meter rise in sea level will result in the loss of over 13,000 recorded historic and prehistoric archaeological sites, as well as over 1,000 locations currently eligible for inclusion on the National Register of Historic Places in the southeastern United States alone. Globally, the threat is even more severe. A continental assessment of exposure of 284 African heritage sites shows that 20% of sites are currently at risk, which more than triples under moderate and high emission scenarios. This pattern repeats across every continent, from the ancient ruins of the Mediterranean to the sacred sites of Pacific islands. The Mediterranean, cradle of Western civilization and home to countless underwater archaeological sites, faces particular challenges. The Mediterranean sea level has been rising at an average pace of 2.8 millimeters per year over the past 30 years. This marks an increase in the pace of sea level rise compared with the 20th century average. This accelerating rate means that sites like Heracleion and Pavlopetri, which have survived underwater for millennia, may face new threats from changing ocean chemistry and current patterns. One might assume that archaeological sites already underwater would be safe from rising seas, but this assumption proves dangerously naive. Sea levels have also been rising since the loss of the USS Huron, with an average increase of about 0.06 inches per year over the past century, a rate that has nearly doubled in the past 4 decades. This rise affects the submerged site, potentially reducing the impact of wave energy and sediment dynamics that have protected these sites for centuries. The delicate balance of underwater preservation depends on stable environmental conditions. Changes in water temperature, chemistry, and current patterns can dramatically accelerate deterioration processes. Ocean acidification, caused by increased atmospheric carbon dioxide, is particularly threatening to sites containing metal artifacts, limestone structures, and organic materials. Many underwater sites exist in a state of dynamic equilibrium, where sediment deposition and erosion balance each other to maintain protective layers over archaeological remains. Climate change disrupts these patterns, potentially exposing previously protected sites to destructive forces or burying them beyond archaeological reach. While fully submerged sites face new challenges, coastal archaeological sites bear the brunt of immediate climate impacts. Storm surges, increased wave action, and coastal erosion are already damaging or destroying irreplaceable heritage sites around the world. In Scotland's Orkney Islands, the 5,000-year-old village of Skara Brae, one of Europe's best-preserved Neolithic settlements, faces an existential threat. Skara Brae and the neighboring sites have weathered thousands of years of Orkney's wild winters and ferocious storms, but they may not outlive the changing climate of our modern era. As seas rise, storms intensify, and wave heights in this part of the world increase, the threat grows to these ancient structures. Similar threats face coastal sites worldwide. Ancient harbors in the Mediterranean are experiencing increased wave action that threatens to scatter artifacts accumulated over millennia. Pacific Island archaeological sites face complete submersion as sea levels rise and storm intensity increases. Arctic archaeological sites, preserved in permafrost for thousands of years, are rapidly degrading as warming temperatures cause thawing and erosion. Archaeologists are responding to these threats with unprecedented urgency and innovation. Advanced seabed mapping and computer simulation of lost settlements, as well as additional AI tools, seismic and acoustic surveys, and boreholes are being deployed to document threatened sites before they are lost forever. Emergency documentation projects are underway at vulnerable sites worldwide. High-resolution 3D scanning creates detailed digital replicas of artifacts and structures, preserving their form and context even if the physical remains are destroyed. Advanced photogrammetry captures minute details that may prove crucial for future research. Rapid deployment archaeological teams, equipped with portable scanning equipment and underwater drones, can respond quickly to newly threatened sites. These mobile units can document entire sites in days or weeks, creating permanent records before storms, erosion, or development destroys the physical remains. Machine learning algorithms analyze satellite imagery to identify previously unknown archaeological sites that may be at risk. These systems can detect subtle changes in coastal morphology, vegetation patterns, or water color that indicate buried archaeological remains. Early identification allows for proactive protection or documentation before sites become critical. The scale of the threat requires unprecedented international cooperation. UNESCO has established emergency protocols for heritage sites at risk, but the pace of climate change often outstrips bureaucratic responses. Climate change has the potential to increase the sea level enough by 2100 to inundate 136 sites considered by UNESCO as cultural and historical treasures, creating a crisis that demands immediate action. Funding for emergency archaeological documentation competes with other climate adaptation priorities. Governments and organizations must balance the preservation of cultural heritage against immediate human needs for flood protection, infrastructure improvements, and economic stability. This competition often leaves archaeological sites with inadequate resources for protection or documentation. International partnerships are emerging to share costs and expertise. The European Union's Horizon Europe program funds collaborative projects addressing climate threats to cultural heritage. Similar initiatives in Asia, Africa, and the Americas are creating networks of researchers and resources to tackle this global challenge. Private funding sources, including technology companies and philanthropic foundations, are increasingly supporting rapid archaeological documentation projects. These partnerships combine cutting-edge technology with archaeological expertise to maximize documentation efficiency and minimize costs. Climate threats to archaeological sites affect not only academic research but also living communities whose cultural identities connect to these places. Indigenous peoples, coastal communities, and cultural groups worldwide face the loss of sites central to their heritage and identity. Community-based archaeology programs engage local populations in documentation and protection efforts. These initiatives often reveal oral histories and traditional knowledge that enhance archaeological understanding while building local support for preservation efforts. Community members, trained in documentation techniques, can monitor sites and respond quickly to emerging threats. Cultural tourism, an important economic driver for many coastal communities, faces disruption as heritage sites become inaccessible or degraded. This economic impact creates additional pressure for protective measures while also generating resources that can support preservation efforts. The loss of cultural heritage sites affects community resilience and identity, particularly for indigenous peoples whose spiritual and cultural practices connect to specific places. Documentation efforts increasingly focus on capturing not only physical remains, but also intangible cultural knowledge associated with these sites. Faced with the impossibility of protecting all threatened sites through traditional conservation methods, archaeologists are developing innovative approaches to heritage preservation. In situ protection uses artificial reefs, sediment management, and engineering solutions to create protective environments around vulnerable underwater sites. Some projects relocate portable artifacts to controlled environments while leaving architectural remains in place. This selective preservation focuses resources on the most significant and transportable materials while acknowledging that complete site preservation may be impossible. Virtual reality and digital reconstruction technologies create immersive experiences that preserve the cultural and educational value of sites even after physical destruction. These digital environments allow researchers and the public to explore reconstructed ancient cities, experience historical events, and understand cultural practices in ways that traditional museum displays cannot achieve. Advanced materials, science contributes new conservation techniques, specifically designed for underwater environments. Nano-coatings protect metal artifacts from corrosion, while biocompatible materials prevent biological growth without disrupting marine ecosystems. These innovations extend the preservation potential of underwater sites while minimizing environmental impact. The race to document and preserve underwater cultural heritage represents one of archaeology's greatest challenges and opportunities. Success requires continued technological innovation, increased funding, expanded international cooperation, and growing public awareness of the irreplaceable value of our shared cultural heritage. Climate change will continue to reveal new underwater archaeological sites as storms and erosion expose previously buried remains. This creates opportunities for discovery, even as it threatens existing sites. The archaeological community must balance rapid documentation of newly revealed sites with efforts to protect known heritage locations. Artificial intelligence and machine learning will play increasingly important roles in processing the vast amounts of data generated by emergency documentation efforts. These systems can identify patterns, connections, and significance across multiple sites and time periods, accelerating research and understanding even as physical sites disappear. The integration of archaeological documentation with climate science modeling. As we surface from our journey through the world's sunken cities, we emerge with a profound new appreciation for the complex relationship between humanity and the sea. The drowned civilizations we have explored represent more than archaeological curiosities. They are windows into our past and mirrors reflecting our present challenges. From the temple columns of Thonis Heracleion, reaching through Mediterranean waters toward a sun they will never again feel, to the ancient streets of Pavlopetri, where Bronze Age merchants once haggled over precious goods, these underwater ruins tell a story of human ambition, ingenuity, and ultimate vulnerability. They remind us that even the greatest civilizations can vanish beneath the waves. But they also demonstrate the remarkable resilience of human culture and the enduring power of discovery. The technologies that have revealed these hidden worlds represent some of humanity's greatest achievements in engineering and scientific innovation. From the sophisticated sonar systems that map the ocean floor to the robotic explorers that serve as our eyes in the depths, these tools are expanding the boundaries of human knowledge and capability. They prove that even in an environment as hostile as the deep ocean, human curiosity and determination can unlock the secrets of the past. The lessons from these sunken cities are more relevant today than ever before. As sea levels rise and climate patterns shift, coastal communities around the world face challenges remarkably similar to those that overwhelmed ancient civilizations. The archaeological record beneath the waves offers both warnings about the consequences of environmental change and examples of how human societies can adapt and survive in the face of overwhelming natural forces. Perhaps most importantly, these discoveries remind us that our planet still holds countless secrets waiting to be revealed. The ocean covers more than 70% of Earth's surface, yet we have barely begun to explore its depths. How many more lost cities lie hidden beneath the waves? What other chapters of human history remain to be written based on discoveries yet to come? The golden age of underwater archaeology has only just begun. As our technologies advance and our understanding deepens, the ocean will continue to yield its treasures, revealing new aspects of our shared human story. Each artifact brought to light, each ancient street mapped and documented, adds to our understanding of who we are, where we came from, and perhaps most critically, how we might navigate the environmental challenges that lie ahead. The cities beneath the waves will continue their eternal wait in the depths, patient guardians of humanity's past and silent teachers for our future. They remind us that civilizations rise and fall, coastlines shift and change, but the human spirit of exploration, discovery and understanding endures. In seeking to understand these drowned worlds, we ultimately seek to understand ourselves and our place in the vast, interconnected story of life on Earth. The ocean keeps its secrets well, but human ingenuity and determination are proving more than equal to the challenge of unlocking them. As we continue to push the boundaries of underwater exploration, we can be certain that the most remarkable discoveries still lie ahead, waiting in the mysterious depths of our blue planet. As we surface from our journey through the world's sunken cities, we emerge with a profound new appreciation for the complex relationship between humanity and the sea. The drowned civilizations we have explored represent more than archaeological curiosities. They are windows into our past and mirrors reflecting our present challenges. From the temple columns of Thonis Heracleion, reaching through Mediterranean waters toward a sun they will never again feel, to the ancient streets of Pavlopetri, where Bronze Age merchants once haggled over precious goods, these underwater ruins tell a story of human ambition, ingenuity, and ultimate vulnerability. They remind us that even the greatest civilizations can vanish beneath the waves, but they also demonstrate the remarkable resilience of human culture and the enduring power of discovery. The technologies that have revealed these hidden worlds represent some of humanity's greatest achievements in engineering and scientific innovation. From the sophisticated sonar systems that map the ocean floor to the robotic explorers that serve as our eyes in the depths, these tools are expanding the boundaries of human knowledge and capability. They prove that even in an environment as hostile as the deep ocean, human curiosity and determination can unlock the secrets of the past. The lessons from these sunken cities are more relevant today than ever before. As sea levels rise and climate patterns shift, coastal communities around the world face challenges remarkably similar to those that overwhelmed ancient civilizations. The archaeological record beneath the waves offers both warnings about the consequences of environmental change and examples of how human societies can adapt and survive in the face of overwhelming natural forces. Perhaps most importantly, these discoveries remind us that our planet still holds countless secrets waiting to be revealed. The ocean covers more than 70% of Earth's surface, yet we have barely begun to explore its depths. How many more lost cities lie hidden beneath the waves? What other chapters of human history remain to be written based on discoveries yet to come? The golden age of underwater archaeology has only just begun. As our technologies advance and our understanding deepens, the ocean will continue to yield its treasures, revealing new aspects of our shared human story. Each artifact brought to light, each ancient street mapped and documented, adds to our understanding of who we are, where we came from, and perhaps most critically, how we might navigate the environmental challenges that lie ahead. The cities beneath the waves will continue their eternal wait in the depths, patient guardians of humanity's past and silent teachers for our future. They remind us that civilizations rise and fall, coastlines shift and change, but the human spirit of exploration, discovery and understanding endures. In seeking to understand these drowned worlds, we ultimately seek to understand ourselves and our place in the vast, interconnected story of life on Earth. The ocean keeps its secrets well, but human ingenuity and determination are proving more than equal to the challenge of unlocking them. As we continue to push the boundaries of underwater exploration, we can be certain that the most remarkable discoveries still lie ahead.